Solar Blade Solar Sail is a spacecraft that utilizes reflected solar pressure as its only means of propulsion and attitude control. The continuous force generated by photons striking the windmill-like sail is sufficient to boost the craft out of Earth's gravity well and eventually out of the solar system. Solar sailing is a revolutionary idea whose time has come. As the limits of chemical propulsion are reached, solar sailing is increasingly becoming an option for extending mankind's reach into space. The promise of solar sailing in space is in the continuous propulsion derived from natural solar pressure. Although the pressure from the sun is less than the pressure felt from a piece of paper on an open hand, its persistent push imparts an accumulated thrust greater than rocket propulsion can provide. Solar sailing makes possible exotic missions once thought impractical due to their large propellant requirements. Such missions include dwelling at Lagrange points, where the gravity from two celestial bodies cancel each other, hovering over an Earth pole for persistent scientific monitoring, cruising to asteroids, and flying to nearby stars. Solar sail concepts have existed for decades, but their implementation has been elusive. To date, no true solar sailcraft has flown in space. The primary dilemma is the need for tremendous sail surface area relative to spacecraft mass. Early solar sail spacecraft designs had payloads weighing thousands of kilograms and sails spanning kilometers. The costs associated with manufacturing very large sails, the risks of deployment, and the complexity of controlling large, flexible structures in space have been prohibitive. The Solar Blade team is overcoming the traditional obstacles to solar sail flight by employing state-of-the-art technology to dramatically reduce spacecraft payload mass, which shrinks the size of the sail and overall spacecraft mass. This reduction of size and weight, coupled with a relatively straightforward deployment scheme of unrolling the sail material, makes the Solar Blade heliogyro design eminently more practical and flyable than previous solar sail spacecraft. The Solar Blade heliogyro has the appearance of a Dutch windmill and employs sail control akin to a helicopter. Its 4 solar reflecting blades are attached to a central spacecraft bus and are pitched along their radial axis. Each blade measures 30 meters long by 1 meter wide and is constructed from ultra-thin polyimide film. Battens provide added stiffness, and embedded Kevlar ripstops resist tearing. The satellite uses collective and cyclic pitch of these solar blades to control attitude and thrust. The spacecraft weighs less than 5 kilograms, and when stowed, is a package approximately the size of a golf bag.
We have main engine start, 0 and
the Solar Blade and its accompanying stowage vehicle launch as a secondary payload and release at an altitude of 1,000 kilometers or higher. After release, a propulsion unit on the stowage vehicle detumbles the spacecraft and points it towards the sun. While maintaining a lock on the sun, the blade rolls release and rotate, and the propulsion unit spins up the spacecraft to 60 revolutions per minute. At this time, the stowage vehicle and Solar Blade separate, leaving the stowage vehicle situated to film the rest of the Solar Blade deployment. Then, the blades feed out in a controlled, balanced manner. The spacecraft will demonstrate attitude precession, spin rate management, orbital adjustment, and station keeping in Earth orbit for a month. Then, Solar Blade will attempt an outward spiral voyage to the Moon. The success of the Solar Blade will pioneer a revolution in spacecraft propulsion by exhibiting unprecedented, fuel-free space flight.